Oh, okay. And can you see? Oh, that's interesting. Josh, somehow your slide was different then. And, okay. That was, I didn't show you that, but Josh did a great job of actually telling you what the median score was on each question also. Okay, I don't know how much effort that was. That was a lot of effort. So I'll put that slide on the web. Okay, and this is interesting. Maybe in recording things are different. So we have learned MVC. Okay, and those of you who started on your projects know it better than those of you who haven't. And we're going to look at some practical applications of MVC. That's a very important concept, and you won't find that subject taught in textbooks. Okay, so it's an important concept for many reasons. You will find in textbooks toolkits taught, but they're not typically taught with MVC, which leads to all kinds of problems in user interface implementation. And so we're going to look at applications of MVC with toolkits. Okay. And some of you have used toolkits before, I know, but most of you, from what I've polled, have not. So there's a lot you can learn here. Okay, and this is very practical stuff. Okay. So when we looked at MVC, when we introduced MVC in the beginning, we looked at a counter application. Okay, and it was a pretty boring application. In the console, you entered your values, input, and maybe you saw the output in the console, or maybe you saw that in a little pop-up window. Okay. It was an interesting way, okay? And the way had to do with MVC. And the idea it was not in the exam, so I know, this is something that if you haven't done the project, you've forgotten, in this last 1 week or so, or more than 1 week actually. So there's a notion of controller, model, and view. Controller is the one that processes input, and it's somehow connected to the model, okay? And the model takes views as observers. So the views are somehow connected to the model through the observer registration method. So that sets things up. And the controller, when there is input, goes and invokes what kind of methods? The write methods. Okay? And the write methods, in the counter case, the write method is an add method. Okay? And it goes and calls this method. So a controller is the one that translates user input into write methods. That's the way to look at a controller. Okay? And the model in response goes and notifies all its observers. And its observers are typically views. In the model view controller, they are views, but they could be other objects also. And in your recitation, you saw a very interesting use of this concept for non-views also. Okay? There were two objects that were model objects that were observing each other, or at least one was observing another. And the view in response, either it gets a notification that's enough for it to display itself, or it goes and calls some read methods in the model. Okay, and in our case, the read method is get value. Okay, and after going and reading that value, it goes and updates the screen. Okay, so please get this into just memorize this or whatever. Get this into your system right now, because we're going to use this again and again and again for the next 25 minutes. Okay, so questions about this? Okay, so that's the model view controller, and we saw that the controller was just reading input from the user and calling the write methods, and the view was just outputting things on the console and or popping a window. So that was kind of the boring stuff, but the architecture was the interesting stuff. Okay, and with a counter, there's only you can make it only so interesting. But here's a little bit more interesting interface that's more akin to what you guys use in your daily life when you use applications. So you're not going to go and enter a value directly. Perhaps you're going to just say increment with a button, and so we've got now a button to go and input a value which increments adds 1, and we see that in the view. Okay, so this is a button and this is a text field. Okay, and the button and text field are together in a bigger object, a frame. Okay, And in Java, there is JFrame and there's frame, and there are two different toolkits. One is the AWT toolkit, and the other is the swing toolkit. And we won't get into the subtleties of how they're different. But so I've used JFrame. I could also use frame, and it has a button and a text field. Okay, so this is a very simple logical structure. You guys have created far more complex structures when you've done your model objects. Okay, so not only do the model objects have a structure, but the display objects also have a structure. Okay. So any questions about this? We've seen this part before also. When we looked at structures, we looked at widgets and the children. And again, after studying, even though there's been a fall break, you probably remember some of that. Okay. Now, how do you think I made sure that these two are in a vertical column and not, say, in a horizontal row? Is there anything in this logical structure that says they should be in a column rather than in a row? No. So how do you think if you're designing Java, what would you do? Would you add something to frame, to button, text field? How would you design the API, Nathan?
Use some sort of panel to organize what you want in the panel.
So you would put into the frame a panel, and you can do that, and then put in the panel a button and a text field. Indeed, you can do that, but that still begs the question: in the panel, should the buttons be in a row or in a column?
Can you not organize them based off of where you want them in the panel north, south?
Okay, so that's good. I need to somehow say north, south, east, west, or something. Who do I say that to? To the button, frame, panel?
I was going to ask, does it work good in the C where it's like it has a question box?
Sorry, say that again.
Does it work the same way in C where it has like horizontal and vertical boxes?
So okay, horizontal box. I didn't even know in C. Okay, so in some extent, C doesn't come actually with a standard library like Java comes with a standard library. But you're saying in C there is something called a horizontal box or a vertical box. So rather than putting it in a panel, I would put that in a horizontal box and then put these objects in the horizontal box or the vertical box. Is that how C does it?
It like has a collection of boxes that you could put horizontal and vertical boxes in, then it just puts them all together as a collection of displays.
Okay, so you're saying there's something called a container that's either horizontal or vertical, and I put things in either a horizontal container or a vertical container. Okay, or maybe something with north, south, east, west. Okay, anybody else have an idea how you might do it? So there's a special kind of container. So this is a container. Frame is a container. Panel is a container. And you're saying we'll just provide different kinds of containers based on what kind of layout we want. Okay. Now there's a separation of concerns principle we guys learned about. And think about that's a solution. A lot of people went that way. But you might want you might want a solution that has a little better separation of concerns. Yeah.
Couldn't you just let the views handle?
So couldn't you let some other object handle?
Right, so you just say, hey, these are the things that I have, and this implements how it's going to be.
Okay, the separation of concerns. Very good. These are the container is I can have things. Layout is how a container should be laid out, and we'll put that in a separate object. Okay, and Java did a very good job of doing it. Okay, the first kind of design you think of is typically the kind of design that you see in C, based on how you interpreted the C design. And here's some code to make this all concrete. So I create a frame, I create a button, I create a text field, I add these text fields to the frame, okay, just as I did before. I set size, I set visible. We have to set up the model view controller in our main. We don't know how to do that right now, so that's something to be deferred. But this is something called, I go and say, frame, your layout is a grid layout. And what do you think this is saying here?
2 width, 1 in height.
So I'm saying 2, it's a grid. So the first argument to a grid must be the number of? So grid is rows and columns. So number of rows and one column. Okay? And I can have one row and two columns, or two rows and two columns. So this is just a detail, how you do that. But the important point is that you see an example of separation of concerns. Okay? Any questions so far? Okay? So we have a separate layout object. Okay? And the nice thing is, when I define a new container class, I don't have to go and define a row container class, a column container class, a row column container class. I just create a container class and the layout class. And I can go and change this layout to a bag layout, to other layouts. You'll see lots of layout managers. Okay? And we won't get into details of those, but that's good. Now we come to the more interesting question that has to do with MVC. So I've got a frame, I've got a button, I've got a text field in it, and we've got this layout manager that's connected to the frame also. So firstly, when the user presses increment, which object in model view controller should go and know that the button has been incremented? So when the increment button is pressed, what should happen at that point?
You should communicate that to the model.
So is increment button, the button press, is that input or output? Input. Who handles input? So the controller has to somehow know about the increment button being pressed. Okay? So this is an input widget. You can have widgets that are both input and output, or just pure output. Okay? So the increment button is and then who updates this text field then? This is input or output? Output. And who will update the output? Okay? So this is an output widget. Okay, that's clear. Now the question is, okay, so by the way, this has a, I guess I should explain this. The has a is to contrast the arrow with is a. Okay, so we draw arrows a lot, and we draw arrows between subclasses and classes. And there's in fact a whole there's a way of making arrows. I mean, there are all kinds of arrows. There's a standard set of arrows that software engineers have come up with that stand for either is a or has a. Has a means what? Is a means that I am a subclass, or I implement an interface, or I'm a subclass of some supertype. Has a might mean what?
It's object properties.
So I have a reference to the object I'm pointing to. And of course, you guys have all been brainwashed with properties, so you think of properties. But classically, has a means I have an instance variable that points to that. I have a real reference. So typically, they imply stored properties. But it's open to interpretation. You can imagine has a also being just a property. Okay, so it has a reference to. That's what it means. Okay, has a reference to. So I'm saying is parent of in logical structure, logical / physical structure. I should update the slide later. Okay, and classically people talk of physical structure. Okay, so what's my output widget? Input widget. My output widget is my top widget. Widget, if you remember, was just an object that is displayed. That's the best definition I can come up with. You can see the guys who invented that name widget just didn't have a good name, so they just said widget. But it's really meant to be something displayed that could have arbitrary functionality. Okay, so the first question we have to answer, which is relatively easy, is that the view, we decided, is going to update the output widget. And again, put on your designer hats. How should the view, what kind of API should be provided to allow the widget or to allow the view to update the text field? This is supposed to be an easy question. So text field is a class, button is a class, frame is a class, view is a class. Who knows how to update? Who's managing the text? So text field. So what kind of method might you have in the text field to update the string? Set text. Okay, that's the easy question. Okay? This is the hard question. And this is the question that Java got and Smalltalk got wrong initially. And they fixed things. And when you went from Java 1.0 to Java 1.1, they fixed things. How should the button tell the controller that it has been pressed? And maybe it's easy actually from what you've learned. Yeah.
Maybe the button is registered with the controller.
So the button will register with the controller? No, sorry. What did you say? Is that what you said? You're on the right track. Sorry. Let me. Zach answer.
The button have to know what the controller is in order to tell it that it's pressed, so it just has all the controllers stored. So in this case, the one, and then it tell it that it's pressed.
So somehow, in the case of the view had a reference to the text field. And the view said, it said set text. Now you're saying the controller has a reference to the, the button has a reference to the controller. And the button was provided by Java. The button doesn't know about our controller quite. So the button has maybe a reference to the controller, and then the question becomes, if it does, what method does it invoke on the controller? Keenan, you were saying something? Keenan, right? I got you.
I feel like the button could just be the controller itself.
Ah, that's interesting. So the button is a controller, but the button was provided by Java. So if button is a controller, then controller would be a button. You would say is a button, right? You would inherit from button. Fred? Is that your name, right?
Yeah.
Okay.
We still. So it's interesting because we have like a controller referencing another controller within references to model.
So the controllers, do they reference other controllers? Controllers all go to a model.
Well, the J button is its own beast, and it's controlling the controller that we're thinking of, which says increment.
Yes.
Which is the method that we should be calling from the J button in the.
Right. So J button has to be, somehow that button has to be heard of, the button press has to be heard by a controller, and the controller, maybe more than one controller will hear it, who knows? And the controller then has to call the add, increment, whatever method the counter had. Right? So the question becomes, we can either subclass button, okay, and the button must have some method in it that gets called when a button is pressed, right? There must be some activity happening there. And if we can override that button, that method, then we can say, super, do whatever you do, and after you've done it, let us go and do the increment. That's one way, the is a way. Yours is the has a way. And the has a way is the button goes and presses, invokes a method in the controller, and then the question becomes, the controller I wrote, right? And so how does it, what method does it call in it? I've forgotten your name. Remind me? Jonathan, okay.
Maybe you could have the button have an object that represents a method call to the controller.
A what to the controller?
Like a method call, like a callback.
Callback. Good. Callback means somebody created me and you call a method back in the controller. And who would decide what that method signature is? I mean, what interface? Standard. Yeah, interesting. Standard interface, right? And all it says is, I've been pressed, right? Does that remind you something from model view controller? Some standard method being called in an object when activity in another object occurs? From the observer pattern? What do we really want? We want the controller to be an observer of the button. We just need a standard observer interface. How subtle is this point? Okay, so object-oriented languages were invented, I told you, a long time ago. And till somewhere in the 90s, people did it Keenan's way. Okay, they said, oh, inheritance is so wonderful, let's just use it everywhere. And everybody they all made the application program a subclass of the widget. And they just trapped the method call and went and overrode it. And then with Java 1.1, they said, oh, this observer interface that was invented actually by Smalltalk, but not used by the Smalltalk guys. This is why I always told you, programming is hard. They went and said, hey, let's use the observer pattern for even these buttons. Okay, so that's why MVC is sort of used in two ways here. We'll use MVC to organize our view and controller and model. Plus, we'll use an aspect of MVC in our toolkit design. So, so now what we have, this was Java 1.1, is the notion of an observable widget. That these widgets that you create are not just these passive things on which you can call maybe methods to change things, but they are things that you can associate callbacks with. And callback is basically calling back in the application that created you. And now in our example, in this MVC case, so we have a model, view, and controller, of course. And now we have these text widgets that we're also using that are provided by AWT or Swing. And there are write methods we saw, like set text. There are read methods like get text. Okay. And now who's going to observe the observable here? So the view goes and calls the write methods. And our observer of the widget is my controller. And the controller goes and says, I'm interested in events from you. Okay? So there's a standard observer registration method that a widget has that the controller can invoke. Okay? So we have two observer relationships. These dashed arrows are going from the model to the view. The view observes the model, and the controller observes the widget. Okay? And you think of the observer-observable interface as being sort of a producer-consumer thing. Okay? So the producer is the observable. It produces information and says, I've got new information. Consumer takes it. And so we have multiple producers and consumers here. Okay? This controller consumes information from the button, changes information in the model, and that information is consumed now by the view. Okay? So, when you say, oh, I do object-oriented programming, what does that mean? Well, I can declare a class. I can instantiate a class. Maybe I can put objects within other objects. Okay? And then I can have model view controller, which is even more complex. And this is getting really complex. See how many arrows I have. Okay? That is OO programming. Every component may be very simple, but the interaction is really complex. Okay? And that's what gets you typically. Okay? So any questions on this? That's the basic. That's the basic idea here. Okay? And so the observable widget calls the notification method in the controller. Okay? And in our example, we had one input widget and one output widget, but you can imagine the same widget being both input and output. I can have a text field that can display some value, like my weight, and then I can edit the text field to change the weight. So the same widget can be both an input widget and an output widget. That means the view and controller both reference it. And that's why some people say, and there's nothing wrong with doing that, but some people say maybe the view and controller should be in the same object. But if you do that, then you can't have two different kinds of input, so you get into those issues. Okay, but there are people who argue that. And let's just go and follow. I've got about 4 minutes left, and let's just follow the interaction to make this all clear. So a counter J button controller is what we'll have now. Okay, so we had a console controller. Now I'll have a J button controller. And it's going to add itself as an action listener. So the standard registration method is called add action listener. Okay? And you guys have seen in the property case, there's a add property listener. This is add action listener, just a different name. Okay? And so the controller goes and calls that method. Now when you press a button, that button is going to result in action performed in the controller being called. Okay? That's going to result in what method being called? What happens next? So when the button is pressed, what do we want to do? Okay. We increment. I hope it's increment and it's not add. I don't know whether it's add or increment, but it's one of these methods, right? And what's going to happen after this now? Set text is ultimately what we want. We're not going to do it so directly. I mean, that would, this is the most roundabout way of doing things you can imagine, and it's got reasons. We want set text to happen, but it's not going to happen immediately. What's going to happen next? So the model has changed. We want the output to change, so what should happen now? Update method is called. What's it going to do? I told you things are very roundabout. And it's going to do the get value, and now what's it going to do? Finally. Okay? That's the joy of object-oriented programming. And it all, it's got its advantages. We can replace components later. But that's MVC. That's two observer patterns working together in one application. Okay? Questions? Okay. Okay, questions? So we were looking at how to build this fancier counter than what we'd seen before. Okay, I've got the laser pointer on right now, so this will be recorded. Where we weren't inputting things through the console and not outputting values through the console, but rather using these widgets. Okay, and one of the widgets is a button. You can press it, and this will increment the counter. And the other widget is this text field, and that's going to show you some text value. Okay. And you've seen these widgets, at least the text field widget you've seen in Object Editor, except that you didn't create it, Object Editor created it. And here, you're going to do it ourselves. In fact, one of the goals here is that you should be able to create the kind of user interfaces you built using Object Editor directly. Okay? So you should be able to write, maybe not Object Editor, but perhaps an Object Editor-like user interface for your objects. Okay, so that's the goal here, and there's plenty of textbooks to tell you how to do that. Okay, and there's plenty of material on the web to tell you how to do that. The question is, how to do it modularly. Okay, and that's where we brought in MVC, which is Model View Controller, and that's something you won't find in at least in textbooks or some of the material, but you will find that if you go to industry or if you program on a mobile platform, you pretty much have to use Model View Controller there. So it's gaining more and more popularity, even though it's something that was developed very, very long time ago. It's only now gaining traction in widespread traction. Okay, so one of the joys of Model View Controller is that you don't do things directly. You do things in a very roundabout way. And the idea is that when this button is pressed, this text field should be updated. Okay? And it should be updated in a systematic way. It should really increment the counter. Okay? Which means we have to go through some model that actually keeps the counter and have it updated. Okay? And we saw the basic idea last time, and that's pretty much what you need to build your own UIs. And we'll just see some concrete code to illustrate what happens. So we saw that so the question, one of the issues was, how does a controller, or how does any application component, because we're using MVC, we'll have a controller, but how does any application component get to know that this system component has had something happen to it? Okay, so this is interesting. You know, we always talk of objects as being reusable components, and you said, okay, let me reuse my my bounded shape class and interface and other classes I developed, and that's some degree of reusability. But we see an extreme form of reusability where the system, or basically the library, is providing you with an object that lots of applications need. Okay, so this is the toolkit. That's why it's called the toolkit, because it's something. It's like a bunch of tools that are used by many different people. Okay, so the toolkit is an object. It's something happened to it, and we need some way to tell us that something has changed. And typically, when they are system objects, we make calls on them. Okay, so if there is text field, we make a call called setText to go and update the state. Okay, that's the API that we all hear about. Okay, that's the API. You know, a string is an object, we make a call in it. Okay, now we want the system object, which knows nothing about us, to make a call back on us. Okay, it has to go and tell us something interesting has happened, do something in reaction. Okay, so we need some form of callback, and we saw there may be two ways to do callbacks. One is through inheritance, is a, one is through has a, and we'll see that duality, or I don't know if I should call it duality, but these two ways in more depth a little later today. And we're going to use the has a principle, where JButton will have a reference to one of our objects. Okay? And in fact, it'll use the observer pattern to go and invoke the callback. So it doesn't really know much about us, except that it knows that our components are observers. Observer, listener, they're synonyms. So it has a method, just as our observable counter had a method that I haven't shown here that said add observer, okay, or it could be add property listener. I mean, there are all these names, they're the same concept. This JButton has a method called add action listener that it defines. It says if you want to go and listen to events, you must go and implement this particular method. Okay, a method in a listener interface we'll see a little later, and that method should be action performed. Okay, and as long as you implement this method, you can register yourself as a listener to me. Just as if the view implemented a certain method, in this case update, it could register itself as a observer of content. Okay, so that's the observer pattern. So we're going to see the observer pattern applied twice in the same picture. Once for the view to get notified about the counter, and the other time for the controller to get notified about the button. Okay, so what happens now? The button is pressed. The button does whatever it does. Maybe it goes and animates the pressing of the button. Okay, so that you see visually the button is pressed. But you want some action to happen in response, and that is done by calling action performed in the controller, in the observer, okay, in the action listener. This is a special kind of observer, which is an action listener. Okay, and what is it going to do? It's going to say, I'm a controller. My job is to translate user input into actions in the model. And I know that the model action I should call in response is increment. And I don't know any more than that. So I will call this method increment, and that my job is done. And the counter goes and says, oh, I'm a model. I just changed. Let me go and tell all my observers about this action being changed. And this is a counter that goes and calls the update method if it was a bean, if it called a property change method. So that's again a detail. Okay? And the counter view says, oh, the model changed. And my update method doesn't tell me how I've been updated. So how the model got updated. So let me go and call getValue to go and figure out what the model is now. Okay, and the model is maybe now 1. Okay, so it says, okay, I know the value. Now somehow I have to render this to the screen. And I know I have a reference to the text field. So I will call setText in it. And now the circle is complete. Okay, so again, very roundabout way of doing things, but extremely flexible. Okay, questions? That's basically it. I'm going to spend a few minutes showing you some code to do it.
What does the arrow going back to the
that these dashed arrows are callbacks. Okay, callback, remember, is sorry. I've mixed these two metaphors. These are arrows that are needed to support callbacks. Okay, so by registering myself as a listener, I get this particular event. Had I not registered myself as a listener, I wouldn't get this event. So, and this event is a callback. Okay, so I should really have made this a dashed line. Okay, and maybe this also a dashed line. And the same thing is that this counter is calling back in the view. Okay, it doesn't know any details of the view, just as the button doesn't know any details of our application. So it's a notification. So these arrows have to do with notifications. Think of it that way. And I should really have made this a dashed line too. I'll try to remember to do it.
Which notification happens first?
So I press the button. So that notification happened first, and that started a chain of events that went here. Okay, it'd be nice if my animations had labels 1, 2, 3, 4. Okay, that would be good. Okay, but if you just play the animation, that's the order in which I went. And you can think that, first the input event occurred, then the model changed, then the view changed. Okay, so it's got to happen in that. Yeah, this is easier to use maybe and harder to understand. A lot of people, a lot of 110 like courses teach this stuff and say, this is magic. Don't ask us how this works. Just plug in your code here, it'll work. Okay, I'm telling you now exactly what plugging in that code really means. Okay? How many of you in your previous course actually dealt with a button or a text field? You did, right? Did you really understand what was going on, or did you just plug in code and say, hopefully it'll work? Sorry?
I understood.
You understood? Okay, good. But you didn't do it using model view controller. So there was did you? No, but earlier. Yeah, so you understood what was going on. Okay, now we'll just see some details concretely. So I have my add action listener. Are you guys liking this laser pointer? Is it distracting? It's okay? Okay, my add action listener takes an action listener as an argument. Action listener is defined as an interface, and it must have an action perform method. Conceptually, no big difference from property change event. Okay, that's a property change event. This is an action event. You'll just see this. You'll just see this in many, many different contexts. Okay. Okay. So if you press a text field, so this action event is something that you can listen to from a text field, from a button, from a menu item. It's a pervasive event. It's an important event. It's a detail, but it's an important. Okay. My counter observable remains the same, no difference. That's the beauty of model view controller. That the same, I had a textual interface using the console, and I had a model created for it. I just reuse it. Okay, I don't have to change anything here. Now my controller is not a console controller, but a JButton controller. And since it's a JButton controller, it must know something about the button. And that button is passed to it by the main method in a constructor. Okay, so the main method is going to do the layout of the button. We saw that last time, actually, that the main method is doing this layout. It's constructing the user interface. And it says, and it also constructed the controller. And it said, hey, controller, this is your button. It doesn't even know which the button is. Okay. And it says, hey, so it has to tell the controller two things. What's your button? What's your model? Okay. So the button it goes and says in the constructor, and the model it says in the setter. And there's no fundamental reason why it couldn't happen both in the constructor. Okay. And there was a process in this particular controller is implementing the same counter controller that we had earlier. So we're just using that controller, and I'm being lazy. I'm not following the same principles that I asked you guys to follow. I'm defining two different interfaces for this particular controller. I should have really united them into one interface. Okay, but this makes it easier for me to explain what's happening. And that counter controller interface had a method called process input, which was this loop that was invoked. After all the activities that occurred, there was this ongoing loop that had to be executed as a last step. Okay, so it was not something you could execute in the constructor. So you executed that in the end. So there was this process input method, which since we are not redefining the controller interface, we just have to implement it and we'll do nothing. Okay, and had we thought far enough, we would have maybe had two interfaces, one with action process input, one without process input. But we're just going to use the controller interface that we had earlier. Okay, and this is the interesting one, that whenever an action is performed in the button, okay, what the controller does in the constructor is not only store what the button is, but add itself as a listener to that button, saying, whenever the button is pressed, I want to know. And what does it do when it knows about that? It says counter add one. Okay, so actually my picture there was not right. I should have been calling the add method in the model and not increment method. I thought I had an increment method, but really I have an add method, and I pass to the add method the value. Okay, so conceptually there's nothing more happening here except that I'm now an observer and I get action performed in it. Okay, and my view, again, it's going to do things with the text field. So it gets from the model, from the main method, the text field, exact text field, and it stores that text field. And whenever it gets the update method from the model, it says, my text field, please change your text to whatever the counter value is. Okay, and what do you think I'm doing here? Say that again, I didn't quite hear it. In case it returns null, actually it's an int. So I'm pretty safe there. I might get a 0. Zach?
That makes it into a string.
That makes it into a string. So I really want, the set text takes a string as an argument. I can't pass the int as an argument. But the nice thing about the plus operator is that it's an overloaded operator. If the left argument happens to be a string, it'll convert the right argument to a string too. And that's my easy, there's many ways to do this. This is my simple way of doing it. Okay? Questions? And my composer, the only interesting thing here now is I already talked about this particular portion. And it composes the UI. Okay, so we saw that last time actually. It creates a frame in which it puts a button, it attaches a layout, and it sets it to visible. It sets the frame to visible, and then it goes and composes the model, view, and controller. And since it's got these objects here, it can pass them appropriately to the constructors of the views and controllers. Okay. In my previous composer that I had for the teletype, at the end it will say controller.process input. Okay, it doesn't have to say that any longer. In fact, that method is not even implemented. Okay, that's the basic principle on how to use these widgets in a model view controller. And again, there's lots of information on the widgets. I don't even have to tell you anything there if you want to search. And there's not really any new concept I can tell you. But the trick is to put it in MVC, and that's what I really told you. And what I told you through graphics, I'm telling you here in text, your leisure. Okay, so like I said, and I want to make this point the first part of your next assignment, that is to write just because you guys were using Object Editor, the second part is saying you've already been creating almost models. Okay, you've been creating these objects that don't have any UI in them. Because I don't have to answer questions. And now what we've done by making them models is just make them observable. Okay, that's the only thing we've done. Answering questions. So one of my reasons for doing Object Editor was to make sure that you don't have this spaghetti code where the semantics and the UI are all mixed together. And if I had started off with toolkits and said, here's the button, here's this, and told you go implement, you'd go and just implement some mesh of objects that may not have a clear division of labor. Okay? So what I did was I said, let's just think of semantics, the geometry, the BMI computation. Let's not even think of the UI. And that's separate concern. And we'll just build with that. And now that we are halfway into the semester, you can now attach your own UI. And you attach UIs to the objects you already created. Those objects did not have any UI in them, so the UI and the model are separate. Okay? That's, I mean, if you go look in the web and say, what is the most fundamental software engineering principle, they will say separation of concerns. Okay? And what you've learned is an important form of separation of concerns, which is the semantics is different from the UI. Okay? So by having an object editor that had its own view and controller, which you didn't see, which understood any model you created, I made sure that you kept the same. Now what you can do is that now that you have these models, which have which you don't even have an import of the object editor. I mean, if you were doing refresh, maybe you had an import for that. But refresh was not a good thing anyway. So your models don't have any, they're totally oblivious to the UI. There's not even an import of an AWT component or an object editor component. And now you can attach your custom controller and custom view to the models. And that's exactly what you will be doing in the assignment I'll write today. Okay? The idea is that you are now empowered to do this. Conceptually, you know what's required. Rest is all details and to be looked up. Okay? Questions? And you can have lots of fun. I just want to show you very quickly. I won't go through the code. But I want to just show you the advantage of keeping the model, view, controller, and the composer all separate things. Okay, we have 4 different kind of entities. There's this composing main method, there's a model, view, controller, and you know, what if I want to put the increment button and the counter view in separate frames? Okay, I already have a view that can display any something in a text field. I already have a controller that knows how to listen to increment buttons. It doesn't know where the text field came from, whether it was in the same in the same frame as the view as the text field or a different frame. So all I have to do is change the composer, keep everything else same, and I get this UI. And that's what, you know. So the composer goes and creates a different composition of widgets. The MVC composition remains identical, and I have now this UI. And I won't go through this, but this is the composer that goes in. And it's not this monolithic main method that just did everything together. It was not a nice thing. I just wanted to fit it all in one slide. But now it divides its activities into multiple methods. If you want to be even more good, if you want to be better, we can even go and replace it, have multiple objects there. Okay? I could go and say, I want to go and have a single frame in which I have a menu item in which there's an increment button. This is becoming more like object editor now, that I press rather than having this button. Okay? So what changes? My view remains the same. It has a text field. My controller now has to worry about a menu item rather than a button. Okay? It so happens the menu item also does. And so I have a different architecture now. I have a menu. Sorry, this should really be a menu item here. I have a menu item in a menu bar, in a frame. I have where I had a J button. I'm going to replace that with a J menu item. And here's, you guys are maybe still not convinced about interfaces, and that may have cost you a lot of points in your midterm. But had Java done things right, when I replace a J button with a J menu item, I shouldn't have to change my controller, because both the J button and the J menu item should implement the same interface that allows add action listener. Okay? As it turns out, J button and J menu item do not implement a common interface with add action listener, so I have to create a special counter J menu item controller just because it has to understand a different type than, even though all it's caring about is the add action listener, it just so happens J menu item is a separate class without a common interface. And I keep telling you that even smart people get object-oriented programming wrong, and this is an example of that happening. Okay? But that's all. That's all the difference. No changes. So here I'm just, saying what should have happened in Java and what didn't. I'm going here. Oh, so rather than using J text field, I can use text field. Okay, so text field is a different entity than J text field, and as it turns out, it's a different. It doesn't have the same interface, so I have to go and define a different control. That's just a detail here. Things could have been better, And here's my menu item controller, and it's the same as a J as before, except it's got a JMenu item as in a constructor. Okay, so for extra credit, I'm going to allow you guys to create menus. That's why I just have this detail in this slide deck. If you want to do the extra credit, conceptually, you're not going to learn anything more. So I really don't care whether you do it or not. Okay, composer. And counter is a very simple object. It has one kind of observer interface. You know that your beans have different interface, different kinds of observables. So you will be attaching things to beans actually. So things become a little different in the details, not in the concepts. And here's some code that shows you how to take a BMI spreadsheet and display it not using Object Editor, but your own UI. Okay? And here you've got your height displayed, your weight displayed, and where's the BMI being displayed, you think? I've got this thing which is really a slider. So I just go and see it in a scale, and I've got this thing which is a progress bar. I just want to show you that there are these two widgets that Java provides you with. And you can show the BMI simultaneously using two different widgets. There's nothing wrong with that. Okay, that's one of the things you want multiple views of the same entity. Okay? And so just to show you how progress bars and sliders could be done, again, you can look in the web and probably find better information. But if you want to look at the slide deck, you can just see some code here on how to do this. And what this shows you is that you've got now a much more complicated window structure. Okay, the frame has got, last time somebody said panels. Yeah, we are dividing things into panels now. So this height is a label. And that and text field get united into one panel. The weight label and text field get united in another panel, which get put into the frame. So you see all this, the joys of creating these broad and deep trees. Okay, that's all you're doing here. And then you've got another tree, which is your logical structure of the semantics, the BMI spreadsheet. And what you're really doing, and this is an important concept, when you do a UI, what you really do is connect a UI tree to a model tree. That's what Object Editor really does. Object Editor says, you've got a model tree, I'll generate this tree and I'll connect them together so that when one changes, the other also hopefully changes. Okay, unless there's some bugs. So that's what you're doing. And so far, Object Editor has been doing it. Now you do it. Okay, and you've got these observer interfaces to help you connect these things together. Okay, that's the point. And the general structure is that this model could be this observable that has an update method. It could be a bean that has a property method. So generally, it's got some write methods and read methods and some kind of registration method thing. And you've got these widgets, and these widgets some of them may be input widgets and some output, or they could be both input and output. So I could have a text field like in BMI. And I could change that field, and that field could serve as an input in that case, or it could also, the same field could also be updated, in which case it's also the output. Okay, and that's when the controller and view, both of them have links to the same field. And when that happens, a lot of people say, yeah, let's just give up separating view and controller. Let's put them in one object. And I would argue that's not a good idea. Let both objects share some objects. There's nothing wrong with that. Peter?
In the previous slide, when you had the slider, what did that actually do?
It just slides. As the number increases, it slides.
But what was the bar to the right?
It's a progress bar. Have you noticed in Eclipse or anything slow? So Object Editor is slow, and I used to not have this progress bar showing how things are going, how time is elapsing. That look, I'm doing something. So saying, please don't give up on me. It's not that I don't know what I'm doing. I'm just taking time. So that's called a progress bar. And you might have seen that in any slow piece of component like Eclipse, it has to load a lot of classes. So when it comes up, it shows you a progress bar. Object Editor has a lot of classes. If you ever get an error from Object Editor, you just see this long a stack trace. And loading these classes takes forever. That's one of the problems with Java, that it does classes dynamically. So that it doesn't just put it all into one big piece of one big memory segment and load it all at one time. It just loads dynamically. So progress bar is something that just tells you time is progressing. Okay, questions? So that's a general. And This is showing you the kind of event flow that will happen with property changed, and it's not different from the event flow you saw earlier. It's just different methods. And the graphical structure, and this is the code for the BMI controller, BMI view. Again, just I know these details are important for you guys. I know you guys just take the code from recitation and hack it, okay, rather than thinking from first principles, which is a lot of us do that. So this is code you can begin with if you want to create. And here's some text, and this is just the same point earlier that looked at a model structures and view structures get bound together. So this is a